I will compare my paper with two different papers. One is obviously by Kruse and Strack. So as I stated before, it's an extension of Kruse and Strack to multiple terminal actions. And this extension includes two parts. One is just pure extending in the same direction. So we basically stack a static mechanism design at the end of the stopping one. So that's one type of extension. The other one is extending into two ways. So you have two types of actions. So it does the binary things, the binary stopping rule, which is different. So in Kruse and Strack paper, single crossing is assumption. So it's sufficient for implementing all single cutoff rules, but here it's both sufficient and necessary. So that I think is the main difference. And also I need to compare it to the Pavan, Segal, and Toikka paper. That paper was really a powerful paper. So I don't want to say that mine is an extension. So mine is a special case when the agent could only choose Qt once. So that thing can actually be simplified to this. So that'll be why I have simple expression for the single crossing condition too. But the main difference is, again, single crossing is sufficient for implementation, but here is sufficient and necessary. So there is a condition called integral monotonicity in that paper that's sufficient and necessary, but I can't seem to simplify this here except for like just restating that as the sufficient and necessary condition for implementing individual stopping rules. And the other difference is that in PST, because it's very general, so there's no closed form solution for the prices. And now, because this is extension of KS, then we do have the closed form solution extended as well. So we have a closed form solution for the prices. And in addition to those two papers, I think the extra thing is basically mainly the binary cutoff thing. So the condition for implementation of the binary cutoff rules is not, as you have seen in the proof, is not really very easy extension of KS because there are more things to work with, and the model with two different types is not really a special case of PST because these two combined in each single period is not actually implementable. So we need to separate them in order to implement them. We are implementing the max. Although we are implementing the max, we need to separate them. But when we have the stopping rule concept, we can actually make them separated. So that's another thing that's extra. And I think one thing that I like is that the single crossing condition in both KS and PST are very hard to explain what they are. They didn't actually explain them in a way such that it can be applied. But here, in my paper, I have interpretable single crossing conditions for examples like in the investment and advice. So in my paper, there are other examples like similar to investment. There is the monopolistic screening example where the buyer buys a certain amount of unit at one single time, and there's the Bayesian hypothesis testing, which is essentially the same as an advice from an econometrician. So we have the reject and not reject, and the agent can keep sampling more from the random variable and reject and do not reject the certain hypothesis at some time. So I think that's one contribution as well. So I guess that's all I want to say about my paper. I would like to thank all of you for attending this presentation, and also I would like to thank in particular Professor Damiano for the comments on the paper, which are very useful. And at the end, the most important person I want to thank is my supervisor, Professor Marshall Pesky, for all the help, which is a lot of help on the paper and the presentation. Thank you very much. In the end.